So thank you for taking your time for my session. It's real-world machine learning with TensorFlow and Cloud Machine Learning. I'm Kaz. I have been working at Google for over 7 years, and now I'm working for Google Cloud team as a developer advocate. Developer advocate is like an evangelist for developers, so I usually go around many different countries, attending many different meetups and events, speaking about the technology from Google, focusing on machine learning and data analytics, things like TensorFlow, which is the open source tool for machine learning, or BigQuery for big data processing. Last week, I was in Google I/O, where I had a session for how to combine cloud IoT and machine learning. And 2 weeks ago, I was in New York City, where I had a session at the AI conference already. So my life is traveling around and talking about the technology. So let's start discussing about the buzzword we are seeing, like AI, machine learning, and neural network. What are those words? So there's no clear definition or scientific definition what is AI or artificial intelligence, but we can say that it's the science of making things smart. So usually the IT system is not that smart as humans. So you have to write program code to instruct how to process data by specifying the detailed instruction by yourself. So we want to make the IT systems a little bit smarter, just like humans, like having a computer recognizing an object in an image, or having a computer recognizing the voices, human voices, things like that. And there has been many different approaches for realizing the vision of AI, and one of them is machine learning, or ML. And ML is very interesting approaches to realize AI, because you don't have to write program code to do ML. Yeah, actually, you have to write a little bit of program code for ML, but you will find when you start using ML, your number of lines of your code will be reducing, because we use data to program the computer instead of the computer programs. Usually, IT systems require human programmers to write down all the instructions for the data processing. But with ML, you will use your data to let computers finding the certain patterns from the data. So that's the idea of machine learning, or ML. And there has been many different algorithms used for the machine learning, like SVM, support vector machines, or random forest, everything. But one of them is neural network. And since 2012, we have been seeing a breakthrough has been happening in the area of neural network. So that's the reason why Google has been spending much development resource on the neural network technology. So what kind of problem you can solve with machine learning? For example, if you have 2 fruits, and your client or customer would ask you, write a program code to classify these fruits as an apple or orange, what kind of Java code or C program code or Python code you would write to classify these fruits? Maybe easiest way is to looking at some pixels and take an average of the colors, whether it's red or orange, and write an if statement with a condition. If it's an orange, maybe it's orange. Or if it's a red, it must be apple. But what if you have a monochrome image like this? What kind of the program code you would write to classify these pictures as an apple or orange? So at this point, maybe it's really hard for you to write if statements or SQL statements to define a condition how to detect each fruit is an apple or orange. So this problem could be solved by the neural network machine learning instead of using the traditional programming code. How about these images? What kind of program code you would write to classify these images? These look like mops or bloom, but if you take a look at carefully, then some of them are actually dogs. They are called sheepdog. They are not mops. What kind of Java code you would write to classify this as a dog or a mop? It's almost impossible. But if you use machine learning, neural network, actually you can classify these at a decent accuracy. It's not 100% accuracy, but with machine learning, you can get a decent accuracy such as in 99% or 98%. By using Cloud Vision API, you could get the result like this. So it's not so bad. And any machine learning algorithms usually cannot achieve 100% accuracy. So that's where you may want to have some expectation control with your customer. With ML, you cannot achieve 100% accuracy, but with 90% or with 80%, maybe ML can help the increasing the humans' productivity at work or business. And how neural network works to help to solve these problems. You can think that neural network as is a function. So it's just like a calculator, pocket calculator. You can input some numbers, then you can get the output numbers. So for example, if you want to classify these images as a cat or dog, you can dump many different training images with cat images or dog images, many different images, to train the neural networks to extract certain patterns, whether the image is a cat or a dog. And important point here is that you can apply this technology to any kind of data you have. For example, if you have your own game server and have been collected user activity logs, then you can try converting those user activity logs into vectors so that you can try training neural networks to classify these user activities to whether the user could be a premium user or maybe a cheating user, fraud use cases. Or if you have a credit card credit card service, you can use the neural networks to classify whether credit card user activity could be a fraud activity or proper user activities. But the basic mathematicals used in the neural network is very simple. It's not a rocket science. It's just a bunch of the multiplication and additions between vectors and matrices you have learned at high school or maybe first or second degree of the universities. Let's take a look at how the neural networks can solve your problem. It's the simple problem. In this sample data, we have 2 dimensions, 2 kinds of data. And if you plot those data points, you will see there's 2 different groups, orange group and blue groups. This is called double spiral patterns used for the classification problem for machine learning. And if you are human, it's really easy to classify these data points. If you have new data points here, it must be orange. These data points here must be in blue. It's so easy for humans. But what kind of the Java code or C code, Python code you would write to classify these groups into 2? Maybe you can try to write the equation for the spirals, but what if you have totally different patterns, complex patterns? Every time you have to update your if statements, conditions, or SQL statements. Instead, you can use neural network or machine learning. This is a demonstration where you can actually train your simple neural network model inside the browser. This is called TensorFlow Playground, where anybody can play with your own neural network configuration. So when you started the training of the neural network, it doesn't make sense on the data. So the accuracy you would get will be pretty low. Neural network now thinks all the points around here would be orange, and all the points here must be blue. So it doesn't work. But if you're continuously training the model with much training data and computing power, then gradually neural network tries to find the best way to classify these points as orange or blue. And finally, you would have pretty good ML machine learning model with the high accuracy that can classify the data points as orange or blue, as accurate as humans. So that was the basics of neural network. And I have demonstrated with 2-dimensional data, 2 kinds of data. And you can extend these techniques to any number of the dimensions. For example, if you have an image data with 28 times 28 pixels, that means you have the 784 dimensions of data. Then you can use the 10 neurons. We have 10 neurons to classify these pixels has the digit of 8 or not. For example, this neuron can be trained to recognize if there's a handwritten digit 8 in the pixel or not. So by training these neurons, you would have the so-called weights between the pixel data and the neurons. So after the trainings, this neuron would have a weights that will be looking at a certain position of the pixels, like these pixels, so that it can easily calculate the probability of having the digit as an 8 or 9. So it's a very simple mathematics they are used in the neural network. But if you have multiple layers of these neural networks, like a 40 or 80 neural networks, that is so-called deep neural network or deep learning. At Google, we are using the deep learning model with 40 or 80 hidden layers between input data and output data for the production image recognition. And very interesting things can happen when you are using that kind of deep neural network model. For example, the neurons close to the input image could be trained to recognize very simple patterns such as edges or patterns. Neurons inside the intermediate layers could be trained to recognize animal eyes or nose. If you go to the higher layer, the neurons can be much smarter that can recognize dog snout or cat leg. Eventually, you would have neurons that can be excited when they have the Labrador retriever or tiger cat. You can classify the species of the animals. So that's the basic of the deep neural network or deep learning. And Google has been using this technology for implementing many different products in Google. For example, if you are using Google Search, that means you have been using the deep learning from Google every day. Because in 2015, we have introduced deep learning-based ranking model as a part of the signals for Google Search ranking results. And we have over 100 production projects inside Google that has been using deep learning model, not only the traditional machine learning models. For example, Google Photos is one of the most successful applications for the deep learning for mobile applications. So nowadays, you don't have to put any tags or labels on the photos by yourself. You can just use Google Photos and type in keywords such as boats or flowers or mountains to find the object in the images. The email applications such as Inbox or Gmail has now the smart reply feature that shows the buttons, options to reply to each email thread. That uses the neural network model to recognize what kind of the conversation you are having in each email thread. Are you having a conversation with your friends or family, or is it your business partner, customers or business colleague, or is it just a direct mail or something like that? And last week at Google I/O, we announced a new feature called Smart Composer, which allows you to, which shows a suggested text while you are composing an email text. That is all based on the neural network technology and deep learning technologies for the natural language processing. Google Translate introduced a neural machine translation model 2 years ago, and that has increased the accuracy, especially the fluency of the translated text dramatically. Google Data Centers is now using deep learning model for controlling the air conditioners in data center buildings, because the air conditioners and its power consumption is the most important factor for reducing the total cost of the operating data centers. So we asked the DeepMind team, the AI team in the DeepMind, the Alphabet company, who has built the AlphaGo AI. They have built a deep learning model for real-time controlling of the air conditioners on the data center. And they were able to reduce the 40% of the cooling energy. So deep learning is not a hype anymore at Google. It's a real production quality technology we have been using for the last 4 or 5 years. So we expect the developers will be using the same technologies in coming years. So that's the reason why we are focusing on externalizing the machine learning technology as a Google Cloud products. We have 3 different kinds of products, starting from the ML APIs, AutoML that would allow you to customize your own model. And TensorFlow, this is a design for the data scientists and data engineers. Let you design your own machine learning model from scratch. Let's start with the ML APIs. ML API is the easiest way to get started with machine learning from Google. You don't have to have any machine learning expertise or experiments on using that. So please go to cloud.google.com and find out the product page for the ML API, like a Vision API, Speech API, where you can try the API without any sign up or paying any cost on that. Anybody can try the API today. For example, if you go to the Vision API product page, anyone can try Vision API by drag and dropping your own images to the box. For example, if you upload the sheepdog image, then you'll be getting the labels such as dog or mama, or dog like mama, not bloom or mop. So you can easily understand what kind of the label or accuracy you would get when you are using the Google's vision recognition technology. And you can do the same thing on the other APIs, such as Speech API, where you can choose one of the 80 languages we support with the Speech API and speak to your own laptop so that you can start recognizing your word in real time. This is the same technology we are using for the Google Home or the Android voice recognition. And we provide those the state-of-the-art voice recognition technology as API. And then you can copy the recognized text to the other API, natural language API, to get more insight in the text. You can just put the button, press the button, so that you can get the analysis results, such as the entity analytics or sentiment analysis, where you can understand whether the statement is talking about positive or negative, or you can get the syntactic analysis result. You don't have to hire your own specialist for the natural language research. You can just use the NL API to find out, to get the deep insight on the text. And we recently announced a new product called AutoML. This is the second kind of the ML products we provide. This lets you customize your own machine learning without having machine learning expertise or experience. So the downside of the ML API, such as Vision API or Speech API, is that those APIs are all pre-trained models. That means you cannot train your own model. And if you want to customize or build your own model, for example, if you want to recognize certain customers' products, then you have to hire a bunch of the data scientists and data engineers, prepare for the tons of the images for training, and set up all the clusters for the distributed training, image training, and verification, deployment, everything. That would cost like hundreds of thousands of dollars or maybe millions of dollars. But with Cloud AutoML, we are trying to reduce that cost by automating almost the major part of those data processing pipeline. So with AutoML Vision, that lets you customize your own vision recognition model. All you have to do is upload all the training image data with the labels in the CSV file, upload it to the Google Cloud storage, and then press the train button of the AutoML, so that it would take like 1 hour to 24 hours to train your own model, so that you can easily start evaluation of the machine learning model. Let's take a look at the demonstration video. If we have Wi-Fi. Is it connected? Yeah.
The model with Cloud Machine Learning Engine. Let's say you're a meteorologist and want to train a model to identify different types of clouds, like cumulus, cumulonimbus, or stratus, to predict upcoming weather patterns or flight plans. If you tried this with the Vision API, here are the labels you'd get back. It wasn't trained specifically to identify different types of clouds. What if you want to train a model to classify images specific to your dataset without writing model code? Cloud AutoML Vision lets businesses and developers with limited machine learning expertise train custom vision models for their own use cases. Developers can upload their own labeled or unlabeled dataset, train and manage their models, and use those models directly from the cloud to make predictions. Let's take a look at the AutoML UI. Begin by uploading your images to Cloud AutoML. Then, press the Train button to train a custom model on your image dataset. When training completes, analysis and stats of the model quality are available directly in the AutoML UI.
So that's so easy. You don't have to be a data scientist or expert data engineer. Instead, you can just collect data and press the train button. And we started to provide more and more of the AutoML products, but the Vision was the first product, and we hope to announce more products coming this year. And this is one of the early experiments on the AutoML by our customers, predicting ramen shop. So I need to explain what is this all about. And there's a very popular, does anyone know what is ramen? Oh, you know, thank you. It's a Japanese noodle or Chinese noodle. And we have many ramen shops in Tokyo. And Ramen Jiro is one of the most popular ramen ramen chain stores in Tokyo. And they have 41 Ramen Jiro branches in Tokyo. And there was one data scientist who collected 48,000 pictures of the Ramen Jiro bowls collecting from the 41 different branches. And so they are all Ramen Jiro bowls, but they are from the different branches. And he trained the neural network model with AutoML by putting the 48,000 images to the AutoML. Then the model was able to predict or classify the branches of the ramen bowls at 95% accuracy. So as you can see, the shape of the bowl or the color of the table are all the same because it's their franchise shops. So the only difference you could see is how they serve the toppings, like vegetables or how they cut meat. And AutoML model can detect those very little differences, subtle differences on the servings and achieve the 95% accuracy. So this is one of the very amazing outcome we got. Another use case is the predicting brand names. Mercari is one of the most popular selling applications in Japan, and they are trying to put brand name suggestions when the seller uploaded the image of the branded products such as Gucci or Chanel or everything. And they have been hiring their data scientists to build such a model, and the accuracy was something like 75%. But when they tried AutoML Vision, they were able to get the 90% accuracy in one day, just pressing by train button. So that's the power of the AutoML. Behind the scenes, Google has been putting the latest state-of-the-art technology for building the machine learning model. But all you have to do is pressing the training button. So that was the power of the AutoML. But sometimes you may want to hire the data scientists or the data engineers to build a machine learning model from scratch, to customize everything to meet with the customer's requirements. And TensorFlow is the best solution for those cases, where you have the data science experts or data engineers and write a TensorFlow code with Python code to build everything from scratch with the training data. And TensorFlow is originally our internal tool for building our machine learning or AI models. And we have open sourced it in 2015. And it supports the neural network or deep learning, but also it supports the other machine learning algorithms such as K-means or decision trees, SVM, random forest, and the Bayesian networks and things like that. And it's scalable and portable, so you can start using the TensorFlow with your own Mac or Windows. And if you think it's too slow to use your Mac or Windows, then you can move your TensorFlow code to a GPU servers, or maybe tens of GPU instances in Google Cloud or any other cloud. So it's scalable. You could have tens or maybe 100 GPU instances for the distributed training with the same TensorFlow code you have written. And once you have finished training your model, you can move that model to the smaller devices, such as the Android or iOS or Raspberry Pi. We provide the light-weighted model called TensorFlow Lite that runs inside the smaller devices like a Raspberry Pi or iOS. So once you have trained your model with cloud, you can use the mobile phone, smartphones, or embedded systems for using the model, like recognizing objects with camera or recognizing certain patterns of the motion sensors from the Android phones. So with those the benefits, the TensorFlow has been getting the popularity in the world, and it's the most popular deep learning framework in the world, with over 100,000 stars on the GitHub repository. And many enterprises have been using the technology in POC or production use cases, including the cucumber farmers in Japan. And how many people have heard about the cucumber farmer story? Only a few. Maybe I have to explain that. Thank you for that. I have taken this picture 2 years ago, and there are a real cucumber farmer in Japan, and he quitted his company as an engineer 3 years ago and started helping his parents' cucumber farming. And he found that most tedious task, time-consuming task for cucumber farmer is classifying cucumbers into different classes based on the shape or colors or length. If it's bended, then it's not a good quality. So his mother had to spend 8 hours a day just for classifying the cucumbers based on looking at shapes and the lengths. And he really didn't want to help that. Instead, he downloaded TensorFlow and took 9,000 pictures of the cucumbers and built his own cucumber sorter by himself. So he bought Raspberry Pi and running the TensorFlow model on it and trained the TensorFlow model with 9,000 pictures. And then the sorter can classify the cucumber just like his mother is doing. His mother is classifying. He spent only $1,500 to build these systems with one farmer. So deep learning is not a AI hype things. If you have one enthusiastic farmer, you can use deep learning to solve your own problem or business problem. So this is the power of the democratizing the AI or machine learning. This is another very interesting use case. He is the owner of the very small laundry shop in Japan. He only has 3 or 5 local laundry stores. And he didn't have any experience on programming at all. And 5 years ago, he started learning Python to start automating everything IT in his shop. And 2 years ago, he started learning about TensorFlow. And now he has the prototype for classifying the items in the laundry stores. And now he got a pretty high accuracy on classifying the items such as the pants or the shirts or things like that. And now his plan is to introduce this technology to automate a major part of the laundry store operation. And you can do that without any experience of the Python or TensorFlow. So it's not that hard technology. It's not rocket science. And Google is trying to externalize and democratize this kind of the AI and machine learning technology and interesting idea in the enterprises and the production use cases. Challenges are the data set. You have to prepare for the large data sets for training, and you have to design good models, and you need lots of computing power. That's the reason how the NVIDIA has been making many businesses these days. The solution is the data center we have at Google. For example, we have been using our own container technology called Borg, B-O-R-G, for over 10 years. The Borg is the foundation of all Google services like Google Search or Gmail or Google Maps. So any Google software engineer can initiate one single line of Borg command to initiate the hundreds of the processes for his or her application. That's the basis or foundation of the Google's distributed computing. And we also have the fastest network called Jupyter Network, We are not using the commodity network routers or switches from the Juniper or Cisco anymore. We have been building the network fabric from scratch by hiring the hardware designers that can hold 100,000 ports of 10 gig or 40 gigabit Ethernet. That yields 1.2 petabit Ethernet as an entire data center. That can connect the the servers with microsecond latency, not like the 500 microsecond latency with TCP/IP on CPU. And we also designed and built our own processor or ASIC chip for running the TensorFlow. That is called Tensor Processing Unit or TPU. The version 2 of the TPU can have the 180 teraflops per chip. And TPU performance is outstanding, and Stanford University is publishing a benchmark called Down Bench. That is a comparison between the different combination of the cloud platform, computing platform, and algorithms and deep learning the frameworks. And now the AmoebaNet running with TPU is the #1 training cost provider. And we also built the cluster of the TPU process that is called TPU pod that provides the 11.6 petaflops performance. That is almost equivalent to the latest supercomputers they are using for high performance computing. And now the TPU pod is also on the #1 of the Down Bench benchmark results. It's the fastest training time on the Down Bench compared by the Stanford University. You can train the whole ResNet 50 model with the ImageNet data within 30 minutes. This is the world record. And last week, we have announced new TPU 3.0 that will be launching in this year. That supports both inference and training. Now we are using the liquid cooling. This is the first liquid cooling system we have introduced in the Google data center. The cluster of TPU 3.0, version 3, that is TPU pod, provides over 100 petaflops. It's 8 times faster than version 2, and maybe 10 times faster than the latest supercomputer or HPC environments. And we provide the TPU as a product from Google Cloud called Cloud TPU. So anybody can go to the Cloud TPU product page and sign up with the product. Now you need to make a request on the quarter, but maybe you can wait for a while and you'll be getting some quarter assignment. And also, we support the TPU on the ML engine or machine learning engine. This is a fully managed platform for running your TensorFlow code on the cloud. So you don't have to think about building your own cluster for distributed training with GPUs and TPU. Instead, you can just specify how many nodes you want to use for training your TensorFlow model with tens or hundreds of GPUs. Let's take a look at some demonstration with ML engine and ML APIs.
Awesome. Okay. All right. So click on that and speak into the mic.
May I have some gum?
So it understood what you said. May I have some gum? Now it's going through natural language processing. It's identifying the noun there, and gum. So now it's trying to. It will then match based upon the model that's been modified. Come on, come on, come on. And it is picking chewy gum. Oh, and there the camera identified extra long-lasting watermelon gum. Now the camera's and over, and there's your gum.
That's great.
Machine learning in an app.
So that was a demonstration how you can combine everything from the machine learning APIs to the TensorFlow model running on the ML engine in a single solution. And the thing is, this is a super low-cost and affordable solution. I have wrote a design documentation for this demonstration last year, and it took only 20 days for our vendors to build this system. And I had to pay only $30,000 for building this system with 20 days. So it's super inexpensive, super cheap system, affordable solution. So this is one example how the democratization of machine learning can help you solving your business problem. So lastly, let's take a look at a few examples how the business enterprises are using TensorFlow and machine learning to solve their own problems. This is a project called Global Fishing Watch. They are tracking the GPS position of the vessels or ships in different oceans, 200,000 vessels in real time. So they are collecting all the position of the GPS of those ships, stored on the Google Cloud storage, using the cloud data flow for the pre-processing, and applying the machine learning model with TensorFlow. And their purpose is to prevent overfishing. So what they are doing with machine learning model is to classifying what they are doing with those ships, whether it's doing a troll fishing or long line fishing or processing fishing. You can get the high accuracy on classifying, detecting those fishing boats by looking at the movements of GPS tracking data. AI Taxi is another example of using the TensorFlow model for real-world solutions. This has been in production since last February. Now in Tokyo, over 2,000 taxis has been using these services for getting the prediction of the demand on each location in the Tokyo city. They're using deep learning model running on the TensorFlow combined with the statistical model to get the prediction.
この移動需要予測技術はドコモの携帯電話ネットワークの仕組みを利
So
用して
they are
作
collecting
成され
statistics from the mobile network, and also they're combining the data from the actual businesses, transactions they are having with the taxis, and applying the deep learning model for getting the demand forecasting. So that the taxi drivers would have the console in the car, where they could have the markers that tells where will be the hotspot for the new customers in the city blocks in next 30 minutes. So those taxi operators is getting the increase on the revenues already. And one benefit you could get is even the beginner drivers, the novice drivers can get the performance just like the expert taxi drivers. QP is one of the major food manufacturers in Japan. They have been applying TensorFlow for detecting bad production on the belt conveyors with their baby food manufacturing plant. So they brought the image recognition system into their real food manufacturing plant with belt conveyors. So, and you can hear the sound. So it sounds like Super Mario, but it's not. The bell tells you the position where the bad potato cube, the potato cube with the bad colors or shapes, will be coming on the belt conveyors. So now the worker don't have to watch out the belt conveyor all the day. Instead, you can just wait for the sound and pick up the bad potato cube when they hear it. Coca-Cola has been providing the applications for doing the OCR on the numbers on the bottle cap. So they are running a TensorFlow model in the application that does the OCR. And so you can get the numbers in the bottom of the cap so that the users, consumers, can apply for any hours or programs. And interesting part of this program is that they are letting consumers improving the quality of the machine learning model because they are collecting all the ground truths, the corrected data from the consumers, so they can keep increasing the quality of the machine learning continuously. Lastly, OpenNet use case. OpenNet is the largest real-time car auction provider in Japan. They have been selling 5 million cars each year, but the problem is that you have to put the labels or tags on the 20 different images for each car, and that would take 15 minutes for the operators to enter one car into the auction. So they have built the used car classifier with TensorFlow and the machine learning model. And by using the machine learning engine provided by Google Cloud, they were able to increase the speed of the training 86 times faster than using a single instance. And the result is a reduced operation time. They were able to reduce the operation time for the entry for the auction from 15 minutes to 3 minutes. And this system has been in production for over 1 year. So this is integrated with their Salesforce dashboard. So the operators can upload the images of the cars, like steering wheels or tires, sheets, so that the systems can put the tags on that. And the most important thing is that Oakland didn't have any expertise on deep learning or machine learning at all when they have started this project. But they were able to find the best partner from the community, because this is the largest benefit you could get with TensorFlow and Cloud AI. The TensorFlow has the largest community and ecosystem in the world, so you could easily find the best partner or consultant or solution on the internet or community or meetups. So they were able to have the 3 weeks of the workshop and training sessions with the consultants, and their IT division was able to learn how to build a production system with deep learning technology. So summary, we provide 3 different kinds of the machine learning services, starting from ML API that is easy to use. AutoML lets you customize your own model easily. And finally, if you can have the data scientists, you can use TensorFlow to build your own machine learning from scratch. So that's it. Thank you so much.